Always store the blue crab blood in 8-liter containers. This will keep you healthy. Where am I? What's going on? Okay, here we go. Fun one today, fun project today. We're going to be doing an engineering challenge. We're going to be working with 3D modeling software. First, we're going to take a look at some standards. Here we go, 9th grade math standards, measurement and dimension, 8th grade, 7th grade, 10th grade. They all have something, somewhat applied to this. So you could use it wherever you need. Here we go. Give an informal argument for the form. You know what, never mind. Let's see, right here. Solve problems, yes. Solve design problems. Okay, we're going to be getting both of those. Wouldn't be a Mr. STEM video without some problem solving. We're also going to be doing rotations, generating rotations of two-dimensional objects, and perhaps even identifying cross-sections of three-dimensional objects. So there we go, right there. Pretty interesting. Let's look at what we're actually doing. So we're going to be designing a liquid storage tank that can hold horseshoe crab blood. Now, what is horseshoe crab blood? Horseshoe crabs live in the Atlantic Ocean. They're often harvested off like the Carolinas coast. So they take these big horseshoe crabs out of the sea. They drain about 30% of their blood and then they release them. A lot of them die in the process. A lot of them also live in the process. And we use that blood to test for the presence of bacteria. So when horseshoe crab blood comes into contact with bacteria, it tends to coagulate, which means it gets thick. So it can detect a bacteria that you want to remove from a vaccine or a medicine. And sometimes, I don't know if it can be used for filtering or not, but anyways, it has a lot of medical applications. It's actually very expensive. You can click on these links right here. It's a tiny bit graphic, but it's pretty interesting. And anyways, so that's kind of the setup of the problem. We want to hold 8 liters of the horseshoe crab blood. There we go. So the tank will be lined with an expensive polymer, and as little as possible should be used. So the inside of the tank, wrapping around the blood, there's going to be this expensive liner that preserves the blood and seals it up. And then the other parts of the tank, like the feet, the handles, the lid, whatever, like we could just make that out of any old metal or plastic, and not a big worry. So what you want to do is you want to create a tank using as little lining as possible that we can use to store at least 8 liters of blood. To do this, you're going to investigate the ratio of surface area to volume of some different shapes, choosing the one that you think will use the least polymer possible. Okay, so here we go. So we're going to test cylinders right here. Tall, thin cylinders, medium, kind of balanced height and radius, short height, large radius cylinders, and you're going to record your findings there. So we're going to look at 3 different cylinders, large height, small radius, so kind of tall, narrow, balanced height and radius, and then short height, large radius. And we're going to look at those 3 and record some observations about them and kind of decide what might make a good tank. Then we're going to look at some other shapes too, cubes and rectangular solids, cones, and finally spheres and other rotation type objects. So you're going to look at those, collect a bunch of data, and then analyze, all right, what's the best shape to use? Obviously, we want to minimize the use of the polymer, but also think about what makes a good tank shape, Okay, so anyways, how are we going to do that? We're going to use a program called OnShape 3D modeling software. It's free, it's available online, and it works, I think, on almost most computers. I recommend Googling OnShape Education right there so that you make sure to navigate straight to the free educational plan, and then you can click on it right there, and you can come up to sign in right here. And you can sign in, and it signed me in automatically. I believe you should be able to click something that says create account right there and get your free OnShape education account. So you'll have to figure that out. Once you come in here, you can see what the dashboard looks like right here. And we're going to come up to this create button in the upper left-hand corner and create a new document. Now let's see, this is cylinder, and this is actually the 4th version I've made here. So There we go. It's going to load for a second, and we're going to make this cylinder on the right here. A large radius, shorter height, and a volume of 8 liters. So let's go for it. So this is the design environment. And if you haven't watched my old video, that gives you a little bit more insight into how to use the various tools. I'm going to kind of cover the bare minimum here that you need for this activity. So these are the planes. This is where you're actually going to be building your 3D objects. Right over here is the view cube. And if you click on different parts of the view cube, you can get different views. And now this is a little bit more fun when there's actually something there. If you get kind of lost in space and you can't get home, you can always go to isometric, which brings you back to a top view or a top, front, and right side view. Okay, so anyways, let's start a new sketch right here. Oops, you know what? Well, okay. If you want to start that sketch, you're going to click right here on the sketch button, and we're going to choose where do we want to build our sketch. Do we want to build it on the top plane, so kind of like the flat plane, a plane going like this, or a plane going like this? I'm going to choose the top plane right here, and you can see sketch 1 appears. Now I'm going to go over to the view cube, and I'm going to click on the top and just kind of move that camera up so I'm looking straight down at my sketch. Now you can see the sketch tools right here changed. So I'm going to get the circle right here, and I'm going to click on it, and I'm going to drag out my circle, and there we go, draw our circle. Okay, now let's put some dimensions on this circle. Let's grab the dimension tool right here and click on the circle. We want to dimension the circle, and you can see it lets me set the diameter of the circle. So you can see that arrow going all the way across and through the center. That's the diameter of the circle. So let's click right here, and we'll just go with 4.6 inches. Now we're designing this tank in liters. 8 liters is 8,000 centimeters cubed. So what I want to do is change the units that I'm working in from inches to centimeters. So I'm going to come up here to the 3 lines, the document menu, and click on that. And then I'm going to open up the workspace units right here. And then I'm going to change the default length from inch to centimeter, and I'm going to click the green check mark. Okay, there we go. We've done it. Now you can notice that my dimension has disappeared, and sketch 1 is actually deactivated right now. So I want to reactivate that. I'm either going to right click, 2-finger click on a trackpad, or just simply double click on it and reactivate that sketch. You can see sketch 1 comes up here. We can change the name. We can call this base circle. Okay, whoops. And we can also click here and change things. Now, I know from previously, I'm going to set the radius at about 30. I think right around there will get us in the ballpark at least, and we're going to click the green check mark. Okay, and we're going to view this in 3 dimensions, and we're going to make that leap from a 2-dimensional sketch to a 3-dimensional object. So we're going to use this tool right here, the very first one. It's the extrusion tool. We're going to click extrude, and we're going to click on the circle. And we're going to be able to drag up and down the height of this cylinder, and we're also going to be able to come up here and type in the height we want the circle to be, or the depth. So 8 centimeters is what I want. Okay, click all right, and there we go. We've built our cylinder. Now let's test the volume and record the surface area. So let's go here and click on part 1. You can see it highlights. And this little button down here, the mass properties appears. So if we click on the mass properties, it shows me the volume and the surface area. Now the volume right now is 5,600 approximately. I want 8,000 liters, so this is too small. So let's see, let's make it a little bit bigger, or maybe a lot a bit bigger. Let's come over here, oops, and let's click on the base circle again, and let's change that from 30 to 40. There we go. All right, click the green check mark, click on part 1 and click there. Okay, now the volume is 10,000 approximately, and the surface area is approximately 3,500, so too big. Okay, we want 8,000. All right, so let's go back. Let's check, I guess let's just try 35 centimeters. There we go. All right, test this one. I'm gonna start speeding up a little bit. 7,696. All right, so we're getting there. We need to go a little bit bigger. Let's go a little bit bigger here. Base circle, let's try 35. Let's go to 36. See what that does. Okay, and check the size now. Again, looking for that 8,000 and 8,143. So we're getting close, right? But it's going to take us a while, and I've tried it, and it does take a while to really hone in and get enough precision to have your tank be about 8,000 centimeters cubed or 8 liters. It takes a while. So I recommend that we do some math to just solve for the radius we need, and it saves time and effort. All right, so if we want to use the formula to find out what the radius is, we're going to have to start with the volume formula right here. Volume equals pi r squared times h. Take that circle and multiply it by the height. All right, so we're going to substitute in our numeric values here. We want 8,000 centimeters cubed for the volume. We substituted in 3.1415 for pi, giving it a little extra precision here. R squared, 8 centimeters for the height. Okay, so we're looking for that radius. First step is to divide both sides by 8 centimeters. So you can see that happening here. We're dividing both sides by 8 centimeters. And here's the result of that division. We get 1,000 centimeters squared. On the left, notice that centimeters cubed divided by centimeters equals centimeters squared. And then the 8 centimeters and the 8 centimeters cancel each other out on the right side here. Okay. Moving on, we're going to divide both sides by pi. So I eliminated a couple lines. I'll show those later. But anyways, we take our 1,000 centimeters divided by 3.1415. We end up with 318.319 centimeters squared equals radius squared. Again, the two 3.1415 cancel each other out. And here we go. Last step is to take the square root of both sides. So we're going to take the square root of both sides, and we're going to end up with radius equals 17.841. And there you go. That's what you do. Here is the entire process, all 4 or 5 steps there. So if you need to pause the video and look at that, you can see it. Otherwise, you can see the step-by-step process if you want to rewind a little. Let's go back to the 3D modeling software. Let's go back to OnShape and see what we can do with this radius. Okay, so 17.841 was our radius that we want to use. So let's go ahead and apply that here. Okay, so now let's click right here, 17.841. Now the problem is the formula uses the radius, the volume formula, whereas the 3D modeling software uses the diameter. So we're going to need to multiply this radius times 2. So you can see, obviously 17 times 2 is going to give us, something close to 36. Okay, so let's click there, and we get 35.682, okay? And let's check this, make sure it's right, and click it, and we got 7,999.784. Okay, interesting. So it's still a tiny bit too small. Let's fix that because we want to get to at least 8 liters. Maybe if it's a little too big, we can live with that. All right, so let's see. And 35.683. 35.683. And let's see here. There we go, 8,000.232. Okay, so that is the volume we're looking for. And you can see the surface area right there. Okay, so let's see. Let's record these observations in our worksheet. Height was 8 centimeters. Radius was, let's see, 17.841. Hopefully I'm remembering that right. Centimeters. Volume was 8,000. What was it? 236, something like that. And surface area, oops, sorry about that. Surface area is 2,896.9. Let's just round it up to the whole number. 2,897. 2,897. So I'm just looking to compare that number to other ones. Oh, and I didn't put my units in here. cm cubed. Maybe I should put a space in there. And then cm squared. If you want to insert the equation, you can. And there we go. So you can compare this. Maybe this would be good to work with some group mates or partners, and you can divide these up. But eventually you kind of get a process down where you can make it, solve it, you know, record the data and move on. So anyways, all right, so let's look at some of these other shapes. These cubes, you guys should be able to figure out pretty well what to do with them. So I guess this is a cube and some rectangular solids, some cones. I'm gonna show you how to make a cone quickly here using OnShape. So let's do that. Let's click up here on the OnShape logo to go to documents right here. And let's create a new document. We'll call this cone V4. And we're going to do something slightly different this time. So we're going to start a sketch as usual. It will work in any sketch plane, but I'm going to choose the front plane right here. And then I'm going to draw a line, 1, 2, 3 lines. Okay. And now, okay, so I have this triangle. And let's view it again in 3D so we can see what's happening. Now, what we did last time was to extrude something like this, right? So that should be familiar, right? How you can extrude something. We're gonna do something different. Let's close the Extrude tool and click right here on the Revolve tool and check this one out. So this one requires 2 inputs. You have to click on the shape that you want to revolve, and then you have to click on a revolve axis. So you can click on a line right here and that becomes the revolve axis. Now if you want to check out a different revolve axis, you can do that and you can do that, right? So there's 3 optional axes of revolution that you can choose. So there we go. I'm going to choose that one. I'm going to click the green check mark, and there you go. Good luck. Have fun. Keep that horseshoe crab blood safe, and see you next time.